Check, check, check 1, 2. Audio's good. It is Friday, May 13th, 2022, and this is another tutorial on Sierra chart coding. This is going to be tutorial 2. Tutorial 1, you can probably find on my channel, and go look through that if you're brand new to this, but this is going to be a continuation building off of what was in that first video, and we're just going to jump straight into it. We have a little template here, a little outline of a program that we're going to make into a C++ study for Sierra chart. Got a 5-minute chart of Apple here, candlestick chart. And what we're going to do is we're going to make a study that has subgraphs. Last time we did a study that had an input and we spat out the input to the debug log. This time we're going to have a subgraph. We're going to actually plot some things on the chart. And so what we're going to do, well, I guess first of all, what is a subgraph? A subgraph is a way to populate data into Sierra chart into a separate region, like right here, down here, maybe like a volume indicator or a comparison of bids versus asks, or something that has to do with price, or something that has to do with the comparison of price and volume. It's a limitless number of things you can plot, but basically it's a plot of line or candles or mountain or any bars, any of the different types, many numerous types that Sierra has. In fact, you can go to like something like current price subgraphs. Here's a subgraph for current price. It's a line style is dot, and draw style is of a line, but you can make points or arrows or stars or whatever. You can set the width, you can set the name, you can set the color, and then it'll plot that current price for you across the chart. So we're going to do something similar, but with a different use case. So a subgraph here is one of these entries that we just saw here, like this. That's one subgraph. So this subgraph that we're putting on line 14 here, that the variable name is s_test. It's going to be the first one. It's going to correspond to this tab in Sierra under this subgraph pane. It's going to be the first one. And so we're going to actually be building a little application, a little study that calculates the number of highs and the number of lows that the stock or whatever the security, the futures contract, whatever it is, has hit in that day. And so that's what we're going to build. So we have Apple here from today on Friday, May 13th. We're going to build a number of highs, number of lows. So the first subgraph that we need to have is we're going to declare it as an SC subgraph reference object, and we're going to give it the variable name s_num highs, and we're going to set that to subgraph 0. And then I'm going to copy that and make another one called subgraph num lows. This is going to store the number of lows that this stock has made, or this symbol has made, and then we're going to put that as subgraph 1. Now we need to define a couple of things for both of these. We're going to do that inside of our set defaults code block here. That's where this is done. And we're going to say s_num highs.name equals number of highs for today. And another thing we can do is set the primary color of this to something like color yellow, for example. And then we're going to do the same thing for s_num lows. We're going to set number of lows, and let's make this red. So all we've done here is set the name that's going to show up in the subgraph tab to number of highs and number of lows. And then secondly, the color that this is going to be as primary color of yellow and primary color of red. Now you can go ahead and set a lot of other things like line style. We can do, I think it's like line style dotted or line style solid. I'm going off of memory here, but I believe that's how it's done. So we can make both of those solids, and you can make this dotted or dashed or a couple of other different things. But you can look up in the documentation, the Sierra Axle documentation, for all the different options that you have here. But that's what we're going to set for our defaults. Now, if we compiled this and added it to the chart, it wouldn't actually do anything because we're not actually having any logic in here counting. We're not actually interacting with either of these two subgraphs beyond just setting their name and their color and their line style. So we need to actually build the logic for this. And the whole point of this study that we're going to build here is count the number of highs and lows that this symbol hit within a day based on the bar period. So if we had a 1-minute bar, we would have the potential to have more number of highs and lows versus a 5-minute bar, which has fewer bars per day, which will have fewer attempts at highs and lows. So what do I mean by high and low? Well, where's the open? Here's the open. So this would be one low gets hit, and then the high would get, and this would also be the high, and the next high, the second high would be this bar right here, and the third high would be this bar right here. This would be the fourth high. This would be the fifth high, right? Sixth high, seventh high, eighth high, ninth, 10th, 11th, 12th, 13th, etc. So this, I'm expecting it to be somewhere around 13 something highs for this day in Apple. And in terms of lows, well, it's probably just going to be 2. The first one for bar 1, and then the second bar is the second low, and we never went to retest the low. And that's just on the 5-minute chart. If we broke it down to a 1-minute or a 30-second or whatever, it's going to have a different result, but this will calculate that based on the bar period that we have brought up onto the chart. So let's go ahead and implement this. The first thing that we're going to need to focus on one side. In other words, just the highs or just the lows. We can't combine the logic together. So let's start off with the highs, since that's what we have more prevalent here. And we're going to need to have a couple of variables, won't we? We'll need to keep track of whatever the current most previous high a day was. That's one. And then we need to see if this current bar's high a day is greater than the previous high a day that we already held. And furthermore, we need that previous high a day to persist forward because this study will get executed on every tick, but it will lose it. We'll lose that variable as this study goes out of scope. This is probably not the right video for a lecture on garbage collection and variable scopes within Sierra Chart's environment. But basically, if this study will run on every tick, and if we hit another tick, but we had a value saved to a variable, it'll get lost if we don't save it. So we're going to use something that Sierra has to allow us to store values that persist between ticks, between function calls, and that'll allow us to achieve that goal. So the first thing that we're going to do, prices are floating point data structures. So we're going to use floats. So let's say float previous high a day, and we're actually going to do it like this with an ampersand here, equals sc.get persistent float 0. And what this is actually doing is it's grab the address, the memory address of float 0. This is a specific piece of blocked off memory that Sierra Chart has provided developers to be able to persist values throughout between function calls. And so what we're doing is we're getting, this returns that memory address, and we're storing that memory address into the variable, into the location that this variable will be pointing to. So we're not actually storing the memory address into previous high of day. No, we're storing the memory address of this into the location where previous high of day is pointing to, so that when we work with previous high of day as a variable, we'll be actually pointing to the value. If this doesn't make sense, that's fine. It's probably out of the scope of this. And I think I have some drawings that I did with the group over at Fat Cat's Discord, and how data structures work and how pointers and references and system architecture works, but that's probably beyond the scope of this video. Anyways, this is what you need to do in order to be able to hold previous high a day between, and between function calls. And basically, if previous high a day has not been set, then we need to set it and initialize it. Also, if the previous high a day is not greater than whatever the current bar's high is, then we need to update it. Those are the two things that we need to do. So the first thing is initialize the previous high day, and the second thing is check if current bar's high is greater than the previous high day. So that one's really quick to do. So we can say that by saying if sc.high of sc.index is greater than the previous high day, then previous high day is equal to sc.high of sc.index. And what that will do is it'll store whatever the high is into here. We may not even need to initialize this because this might be 0. Actually, I think it'll be null, but we'll check that. I think it is null. We might need to initialize it. But this is how we'll do that. And after we do that, what we can do is at the bottom here for every single index, we're going to go ahead and store the number of highs. Now, we're not keeping track of that. So let's go ahead and do that now. Integer, and we're also going to need to keep this persisting. This is going to be numHighs equals sc.get persistent integer 0. So notice that this one was float and this one was integer because this is a type of integer and this is a type of float. And so what we're going to want to do is say numHighs plus plus, we're incrementing it by 1 if we have this. And then what we can do now is plot numHighs onto subgraph. And so where's our subgraph numHighs? And what we'll do is sc.index is equal to numHighs. And that's it. And so now we'll go over to our analysis, build custom study. We'll select a file, tutorial 2. We'll hit build, see what happens. As we're doing a remote compile, that succeeded. So let's go ahead over to our analysis, add custom study. Oh boy, where's tutorial 2? There it is. And there's our 2 subgraphs. So you can see actually this one, snumHighs, is number of highs. We made it yellow. And the line style is solid. And then this one, number of lows, is the second one. It's right here, num lows, and it says number of lows, which is corresponding to here, and it's color of red, which we have here, and it is also solid. And we don't have any inputs, so that's how that works. Let's go ahead and add that to the chart. And I don't see anything. Let me go back into here. Maybe we needed to have added this to a different subgraph, chart region 2. So this actually should have been chart region 2. Number of highs, 0. Number of lows, 0. Now why could that be? And I think the reason is because we are actually not going back in time to do all these bars. We're actually sitting on the most recent bar right here and calculating that. And so this is just doing this calculation for that most recent bar. It's not actually going through. But I'm going to make a couple changes here. The first thing I'm going to do is I'm going to put this on a graph region of 1, which will make it appear down here naturally. And then the second thing we're going to do is we're going to build a loop where we go through the entire day, like this to this. So let's go ahead and make a loop. We're going to make the loop here. We're going to make an integer I. We're going to set it to 0. And we're going to say, well, I is less than sc.array size. And then we're going to say I++. And there's a little for loop. We're going to grab this, paste it in here. And instead of using sc high index, we're going to use sc high I. Now, one thing we haven't done here is do a reset at new day, which is something we'll need to consider, and you'll see why in a second, because once I compile this, what we're going to see is that it won't actually reset at the start of a new day. It's going to just continue incrementing, and that's not what we want. So let's go ahead and take a look at what we got here. And we have number of highs is 7, and it's just plastered right along here. Just right along here. Not even changing. And I think the reason is because this chart goes back a couple of days, and so there must have been something higher, and it's stuck at 7 there. So let's go ahead and implement the new day. And I have to remember how to do this. Gosh, I think the first thing that we need to do is actually grab the time, the date time. We need to have an sc date time object of, we'll call it bar date time. And it's going to be, what is it called? Base date time in, I believe. And from that, we can go ahead and grab an hour, which is bar date time dot get hour. And I think we can grab minute, which is get minute. And what we can do is if the hour is equal to, I don't know, let's just say 9 a.m. just to make it easier. Let's go ahead and do a reset of our variables, which is these two guys right here. Basically want to reset previous day high to 0, and we want to set number of highs to 0 as well. So let's see what those changes do as I build this out incrementally. So I'm going to rebuild and recompile this study here. Let's see if it looks like that was the correct variable name. Let's go ahead and see if this changes. Okay, so that did. So at 9 a.m., when the hour is 9, it's going to reset it. So one problem is that it's resetting it no matter what the minute is throughout the hour 9. So we need to actually add something here that says if the hour is 9 and the minute is 0, then do a reset. Now let's recompile that, because we don't want it to be resetting every single minute between 9 a.m. We just want it to reset the one spot. And actually what we can do is if it's 9:30, that's really what we should do. Let's make it the open. And you can change this to whatever you want, but I'm going to do it for just on the open here. So let that compile. Let's hit recalculate, and there we go. So at 9, we have what looks to be, is this at 0? Nope, it's at 1. Okay, so it's at 1, and then it just starts climbing to 2, 3, 4, and then we get up to 15. And is this the high of the day? It is. That's where we kissed highs, right there. See how that corresponds right there? This point right here corresponds to this point right here. That's the high of the day. So we had 15 highs for this day. Okay, great. Let's do the same exact thing, but for lows. So what we're going to do is repeat these, but we'll say this is previous low a day, and we'll store it in get persistent float 1, and this is number of lows, and we'll store this in get persistent integer 1. And instead of resetting just these two, we're going to also reset low a day and reset num lows. And we need a second check here that says if the low of this bar is less than the previous low a day that we had, then the previous low a day is now equal to the new low of this bar, and then increment number of lows. Furthermore, take the number of lows subgraph, the subgraph for number of lows, right? And store the counter that we're incrementing here every time we get a new low into there. So this is for num highs, this is for num lows. Let's go ahead and build this out. Have this compile. And then let's go ahead and hit refresh, and number of lows stays at 0. Interesting. Interesting. Now, why would number of lows stay at 0? If the SC low is less than the previous low of day, there's the persistent low. Persistent low. Is it because our lows happened right here? And so it reset them? Interesting, maybe. Wonder if it's a time-based issue here. That's actually pretty interesting that that did not. Lows and lows. Previous low a day, low a day. If the low is less than the previous low a day, and the previous low a day, oh, I know why. I know why. This is because we haven't initiated these. That's why. Unless it starts here, in that case, no, because then that should be 0, and that'll never be below 0. So you know what we need to do? Or the previous low a day is equal to 0. So this is the thing. Is the price 143.40? Is that less than 0? Is 143.40 less than 0, which is our initializer? No, it's not. So it'll always fail this, which is why we need a second case, or the previous low a day is actually set to 0, which will allow us to set it, and then we can go. So that is something that's pretty common when you're building studies for financial products dealing with the low of day, and there is our low of day is 2, which is accurate based on what we had discussed in the top of this, what is turning into a very long video. So I'll try to wrap it up here, but you can see that we have now a study that shows the number of lows is 2, number of highs is 15. Let's load something else. Let's load AMD. So AMD had 31 highs on a 5-minute chart and only 2 lows. Well, let's load Facebook. And Facebook had 14 highs, 2 lows. Okay, great. Let me just go over here. Let's load the ES. And wait as market depth loads. And so the ES had 15 highs on a 5-minute candle here and 2 lows. Okay. And so you can make improvements on this. This is, sloppy in the sense of I did it without really having anything premeditated, and I did it just straight on this video as I hit record. Also, you don't really need to start at the very beginning of the chart, which could be days or months or weeks earlier. This is starting at the actual 0 first bar. So whatever is the first bar. So this is the 12th, May 12th. This is the first bar it starts with. We could skip to whatever the most recent bar is. There's a couple of other performance things that we could do to make this better. But basically, just to go through and comment this is grab the date and time for the bar that's being processed. Grabbing the minute and the hour. If it is 9:30 a.m., then reset all our counters. And then it's check if the current bar's high is greater than the previous high. And this one is check if current bar's low is less than the previous low a day. And then we basically set a new high a day, increment number of highs we've had today, and this is the same thing for the low side. Set new low a day and increment number of low a days we've had today. And then it's plot these onto these subgraphs, which we already talked about at the top of the call and defined up here. And of course, you can find even more ways to set this on the Sierra chart documentation. And then lastly for this, let me see if I can pull this up here, which explains, oh gosh, where is it? I just went over, there we go. Here it is. I was doing this explanation for someone else. Basically, when you are using get persistent integer, so I drew this up a couple of weeks ago for an explanation of how to build code for a live stream we were doing on how to prevent a study from running every single tick and have it maybe be like 5 seconds apart from every single time it runs. And it's the same premise. The idea is that you declare a variable, in this case an integer, and rather than setting get persistent int to that integer, you're actually setting the address that this variable is last updated. You're setting the address to be what get persistent int will return. And get persistent int is actually this spot of memory, physical memory on your machine that Sierra chart is allocating when the program starts to be used for this exact purpose, to persist data and variables between function calls, between ticks. So what you're actually getting back is this memory location right here, and I just wrote, let's say it's 10001 is the memory location. That's what you're getting back. You're storing that as the memory location that this variable is actually located at. So it's going to go look in 10001 for the value of whatever last updated is pointing at. So that's how that actually works. When you're doing something like storing 5 into the variable of interval, you're directly storing that into this memory location, and this is pointing to 00001. So this is, how do I explain this in a more concise way? I don't know, it's late. Maybe it's better for a different video. I think I'm biting off more than I can chew here at this time of day. It's the end of the night. And for the purpose of this video, basically, this allows you to, this first one allows you to set variables in scope that will get collected and destroyed rather, once the function has completed. So by the end of the tick, after the whole function is processed, this interval 5 will be destroyed and it will be redeclared and reinitialized on the next tick. Last updated, however, since it is being stored and pointed to this special area of memory allocation that is not garbage collected, it will persist between function calls. And that's why when I call this previous high day number of highs, I'm not losing that number of highs or the previous high day between ticks. I'm not losing it because it's actually getting stored in this persistent memory spot that Sierra chart has given us. And so like if this was the number of highs, first it'd be 0, and then I increment it to 1, 2, 3, 4, 5, 15, but that lives on between function calls. And this is how that allows me to do that. So, okay, that was a lot. This is a long video. So that is tutorial 2 on Sierra chart, and hopefully some of that was useful.